Hi there, this is Mr. Bainey, and this lesson is 5.1, Understanding Linear Functions. The essential question is, what is a linear function? The Explorer that we're going to take a closer look at here is about a race car that can travel up to 210 miles per hour. If the car could travel continuously at this speed, y equals 210x gives the number of miles y that the car would travel in x hours. Solutions are shown in the graph below. So we have 5 solutions to this situation, to the equation shown in the graph. As you can see, the points lie in a straight line. I can draw it actually from 0, 0. That would be in line with this thing. And so I could connect them like that, make it a continuous function. And the graph of the car's speed is a function because every x value is paired with exactly one y value. So that goes back to the last module, how we try to determine whether something was a function or not. And because the graph is not a vertical straight line, it's also a linear function. So linear means it's a straight line. Function means each x is paired up with exactly one output, one y value. Part A asks us to fill in the table of data points. So I know that my x values are going to be 1, 2, 3, 4, 5. Okay, in 1 hour, 210 miles. Then we have 420. Then 3 hours is 630. And then 840. And finally 1050. Part B, using the table, we're going to check that x has a constant change between the consecutive terms. And so that's going from x consists of the x value, consists of the numbers 1, 2, 3, 4, and 5. Does this have a constant change? Yeah, what is the change? It is a 1, or plus 1, I should say. We're adding 1 every single time. Okay, every single time you go down the table. And I forgot to mention this, but a lot of the stuff that we're going to be going through in this lesson, you're going to notice that this term here, linear function, has a lot of very similar features to arithmetic sequences. Okay, if you understand how arithmetic sequences work, how we have a first term and we have a common difference, and we could write the recursive rule or the explicit rule, this all is you're going to see it repeated again in this lesson. On part C, now check that y has a constant change between consecutive terms. So our terms are outputs, if you remember that from arithmetic sequences. And those are the terms 210, 420, 630, 840, and 1050. Okay, we had a term for this when we dealt with arithmetic sequences. We called this the common difference, right? If I want to figure out what my pattern is, I'm adding 210 every single time. And part D, using those answers, what change in x corresponds to the change in y? So the y changes by 210, and the x changes by 1. Okay, this means that when the when the miles, the number of miles goes up 110, the number of hours goes up 1. So that's going to give us a rate that part E, all linear functions behave similarly to the one in this example. Based on this information, a generalization can be made that a constant change in x, okay, constant means the same change in x, will correspond to a constant change in y. Okay, x kept changing by 1s, and then y kept on changing by 210. Okay, let's take a look at this Explorer here for number 2. I would recommend not going through it unless you want to get a sense of how this works using just variables only, and that it works every single time. For something to be linear, you have to know that the changes between the x, the consecutive x's, and the change between the consecutive y's are always going to remain the same. when you go through a function. Okay, and our first vocab that we come across after the first page is this thing called standard form. So a linear equation is any equation that can be written in the standard form expressed below. So standard form is this thing right here, this ax plus by equals c. So a, b, and c represent numbers. Okay, a, b, and c can be any real number. It could be decimals, could be fractions, could be whole numbers, anything like that. A and b, both of a and b cannot be 0. So one of them can, but not both. That's the important part here. Okay, when one of them is 0, you end up with a special type of line. But we're going to look at, most of the ones we're looking at is where a and b are both not 0. So in our examples here, I'm going to do part B. Our direction says determine whether the equation is linear, and if so, graph the function. So part B, we have the equation negative 4x plus y equals 11. And this equation is linear. Okay, we want to compare it to ax plus by equals c. And so it's linear because it's in the standard form that we just saw right above the top. Okay, and it's just like the standard form. If it is, we can identify what a, b, and c are, right? They represent numbers. A is negative 4, right? If you're looking like right up here, there's a. B is going to be in front of where this y is right here, right? That's going to be a 1, and then c is 11. So there you have it. To graph the function, we're going to first solve for our output. We want the output to be by itself. You know, remember when we had the function notation, we usually have f of x equals something. In this case, you want it to be y equals something. So on the right side, we have our equation negative 4x plus y equals 11. We're going to get y by itself, which means I need to get rid of this negative 4x. So let's do plus 4x, right? I can't combine 11 with 4x, so I just get 11 plus 4x. Okay, y equals, let me rewrite this because that blank is really, really big. Y equals 11 plus 4x, 4 times x. So that makes it much easier for us to substitute in inputs and to get outputs. So what I'm really doing is I'm doing x, whatever x is, multiply it with 4, and then add 11. Okay, so go over here to the table of values. Negative 4, go over here. Negative 4 times 4, which is negative 16, plus 11 is negative 5. Okay, if I want to show some work for this, it's going to be y equals 11 plus 4 times negative 4, which gives us 11 minus 16, which is negative 5. Okay, I'm not going to show the work for all of these because I'll do a couple so that you can kind of get the idea here. So we have negative 2 is our next input. So it becomes 11 minus 8, which is 3. Okay, and I'm going to do the rest of these mentally. So if x is 0, it's 11 plus 4 times 0, which is 11. Okay, 11 plus 4 times 2 is 19. And 11 plus 4 times 4 is going to give us 27 total. When I plot this, now here is the weird thing about this graph is that it goes by ones, right? 1, 2, 3, 4. And then on the y-axis, it goes by tens. It goes 10, 20, 30, 40. Okay, pay close attention to that before you start graphing. So our first one is negative 4 comma negative 5, which is going to be like in here somewhere. I probably should have placed that a little bit lower. It's going to be like something like that. Negative 2 comma 3 is going to be like right there. 0 comma 11 and 2 comma 19. Now, if you remember the very beginning of this problem, we claimed that this is linear. So think about why, what does it mean if we say this is a linear function? Well, if you plotted it correctly, assuming you did, then we get a straight line. Well, as straight as I can make it, but it should come out to a perfectly straight line if I make it super accurate, and it's assuming I didn't make any arithmetic mistakes. Okay, try this your turn, number 7. before you see my solution. So determine whether this is linear. If so, graph the function. This is linear because it's in standard form. A is 6, B is 1, and C is 12. So now I'm going to take this function and I'm going to solve for y. So in order to do that, I'm going to subtract 6x on both sides, right, to get rid of that. And y equals 12 minus 6x. So I'm going to do the table of values here, and I'm just going to choose a few. Let's do -1, 0, 1, and let's do 2. Okay. I'm pretty comfortable with you doing 3 if you want to just stick with that. So let's do this mentally. -1. So I got -1 times 6 is -6. 12 minus -6 is like saying 12 plus 6, which is 18. Okay, if x is 0, I'm going to end up with 12. If x is 1, I'm going to get 6. And if x is 2, I'm going to get 0. So let's plot this. I'm going to go backwards here. So 2, 0 is right there. 1, 6 is right about there. 0, 12. And -1, 18. Something like that. And there is my line, because I claim this is linear, so it should lie in a straight line. If you say it's linear, you're pretty sure it's linear, and then it doesn't turn out to be a straight line, then you need to go back and rethink. Is it really linear, or did I make a mistake when I was doing my inputs? Okay, and we'll look at one more here. And before that, let's look at this definition. You've already seen this before, but here's another chance to understand this a little bit better. Discrete function and continuous function. Okay, remember that one of them we do not connect the points, and then the other one we do connect the points. But it's going to depend on the problem, what it's asking, and also if it's a real life problem, we need to think about what type of situation is it and does it make sense. Okay, and let's just go straight to your turn. Okay, if you feel like you can do this, give it a try or get as far as you can before you see my solution. So Christoph rents a kiosk in the mall to open an umbrella stand. He pays $6 to the mall owner for each umbrella he sells. The amount Christoph pays is given by f of x equals 6x, where x is the number of umbrellas sold. Graph the function and give its domain and range. So here's my function right here, f of x equals 6x. Right? So it's already an input-output type of function. It's already in my like y equals thing, so I don't need to do much there. So if he sells one umbrella, right, 6 times x or 6 times 1, he'd have to pay $6, right? So he is the one selling it, like he's getting this money, but he has to pay the mall owner $6. So maybe he sells it for, you know, 10 or 20 bucks so that he's making some money. But he gives the mall owner $6 for every single umbrella that he sells. 2 umbrellas, he would have to pay the mall owner 12 bucks. 3 umbrellas would be 18 bucks, and so on. Okay, 4 would be 24. So if I were to plot this, I got 1 umbrella is $6, 2 is 12, 3 is 18, 4 is 24. Okay. Our domain and range. Actually, before we do that, we want to think, is this discrete or continuous? It actually doesn't tell us that. Tell us to figure that out, but we want to think about discrete or continuous because it will help us with the domain and range, how we want to write it. Okay, so we want to think about, do we connect these points? Well, first, I'm going to mention this. I think in this case, it makes sense to have 0, 0 because think about what that means. 0 umbrellas, Christoph would pay $0, right? I think that makes sense because Christoph could have a day where he doesn't sell any at all. And if I were to connect these, let's do that, and then if it's wrong, I'll erase it anyway. But if I were to connect these, think about what this means. This means that Christoph could sell 2.5 umbrellas and get something like, what's this, 15 bucks. Okay, could he sell 2.5 umbrellas and get 15 bucks? And no, that doesn't really make sense. So we're not going to be connecting that line. That means if we don't connect it, we're really saying it is a discrete function. And if it's discrete, we're only worried about those whole numbers, or the ones that we're graphing mainly. So our domain is our x values, starts with 0 and then 1 and then 2. And then we want to think about how far can he go? How many umbrellas could he sell? And we could put ... All right, with the added thing that maybe, it's probably realistic that he doesn't have an unlimited supply of these umbrellas. He probably has a certain amount, but we can put ... since he could have a lot to sell. And our range is going to be based on the domain, right? 0 umbrellas would be $0, 1 umbrella would be 6, 2 would be 12, 3 umbrellas would be 18, and so on. And that would be my range. Okay, and that is it for this lesson. Thank you so much for watching. If you're watching this right now and want to get some PBIS points, I'll give you a few. If you come to me and tell me what is your function. That's the secret phrase there. What is your function? And thank you so much for watching my videos. Have a great day.